Thank you, sir. Good afternoon, participants. I once again welcome you all to the session 3 of day 4 of this faculty development program on buried energy for conservation and energy management. Today we have with us a young scientist, Dr. Hitesh Panchal sir, as our expert. He is a passionate teacher and an avid researcher. Dr. Hitesh Panchal holds a PhD in solar thermal engineering from KSV University, Gandhinagar. He is currently working as assistant professor in mechanical engineering department in Government Engineering College, Patan, Gujarat. Dr. Panchal has published 100 plus research papers in reputed international journals like Taylor and Francis, Springer, Elsewhere, ASME, etc., and received 4,000 plus Google Scholar citations with H index 40 and I10 index 93. Dr. Panchal has been awarded 28 prestigious awards, which include awards like Tech Guru Award, Pedagogical Innovation Award, SSIP Pratishtha Award, Preeminent Researcher Award, Best PhD Thesis Award, Young Scientist Award, Bright Researchers Award, and many more. Dr. Panchal has completed 2 research projects from Guj Coast and SYST, DST, and currently working on research project under STEM, Grant Education Department, Government of Gujarat. He has filed 26 full patents and 12 industrial designs, and out of them, 2 full patents and 4 industrial designs have been granted. His area of interest includes solar desalination, IC engine emission analysis, automobile engineering, etc. Recently, Dr. Panchal is selected in the top 2% Indian scientists in energy category published by Stanford University. On behalf of BNB Institute of Technology, the organizing team of this faculty development program, and all the participants, I welcome you, sir, and request you to enlighten us with your experience and knowledge. Please, sir.
Thank you very much, sir. So, thank you, sir. So, first of all, let me off my video and let me start my presentation. So, first of all, thank you very much, BNB Polytechnic, for giving me opportunity to share my views on solar desalination. That is a very hot topic. So, let me share my slides. Okay, now I think slide is visible. Okay, so my topic for presentation is research and developments on solar desalination system. These are the contents of my presentation. Actually, a lecture is about 2 hours, so I have taken only 4 to 5 topics in my presentation. And after this presentation, you will understand regarding with the solar desalination. These are the contents of my presentation, like what is solar desalination system, what is solar steel, that is a part of the solar desalination system, then what are the different drawbacks of solar steel, then factors affecting on performance of solar steel, then what are different instruments used of solar steel, then step by step that research and developments on solar steel with fins, with energy storage materials, solar collectors, nanomaterials, then that is called humidification and dehumidification system. And today, as you all are knowing regarding with the machine learning, so what are the some research work have also done on the machine learning that based on the solar state, and last technology. So these are the contents of my presentation. Now, this is called a 2 hours lecture. So actually in these 2 hours, it is my duty to tell you about the learning outcomes, means in this lecture, what will be the learning. So after the end of the session, the participants will be able to understand number one, about the definition of the solar steel, it is basic. Then what are the different factors that affect the performance of the solar steel. Then use of the fins, storage materials, solar collector, nanomaterials, and HDS system, etc. And last, it is very important for future research work on solar steel. Now, in my presentation, I have taken certain figures and content. So actually, I have filed many patents. So in due to filing of patent, it is my duty to explain you that whenever you will take any figure from anywhere place, so you have to cite that particular citation, or you have to write that whatever the figures or contents that you are using, that is only used for the education purpose only. Okay, I am not going to use any content except the education purpose. Now these are the Google Scholar citations. Okay, earlier very good introduction that has been narrated by the coordinator regarding with the citation, that is called around 4,000 plus Google Scholar citations I have, and among the 4,035 H index, that is called a 40, and I10 index, that is a 93. What is H index 40? That means there are 40 or more than 40 articles which have been cited 40 times. And I10 index, that means there are 93 articles which have been cited 10 or more than 10 times. That is why the I10 index is around 93. Let us start my present lecture. Now, first of all, my title is desalination. Okay, solar desalination. So, first of all, we must understand very well regarding with the what is solar desalination, what is desalination. So, here for the simple understanding, I can say you that one figure. In this figure, you can see two beakers are there. One beaker has a, we can say that saline water, that is called unwanted water, and second beaker, that is a pure water, pure, we can say water. So from the figure or the picture itself, I can say that desalination is a process in which the saline water is converted into the potable water. I am repeating further, a desalination is a process in which the saline water is converted into the potable water. Okay. Now, if I will use the use of the solar energy for the conversion of saline water into the potable water, so it is called the solar desalination. Okay, so this is the basic difference between the desalination and solar desalination. Now, second one, that is called what is solar steel. If you will see my research articles, so maximum research articles have published in the field of the solar steel. Okay, so what is the meaning of the solar steel? So here for the understanding point of view, I have put two figures. One is an experimental setup and other one, it is called the line diagram. Okay, so solar steel is a device in which the saline water or unwanted, we can say that brackish water, is converted into the potable water with the application of the solar energy. It is very simple device. I think if you will see the figure, so definitely you can understand very well how it works. Now in the solar steel, you can see there are two processes called the evaporation process as well as the condensation process. Here in the solar steel, there is a basin. That basin contains the brackish water or saline water. Okay, whenever the solar radiation will be incident on the glass cover. Okay, glass cover, it is placed at the top of the solar steel. So whenever solar energy is incident on the glass cover, so after passing through the glass cover, it will come into contact with on the water which is stored on the basin. So due to the sun rays, what will happen? Your water will be evaporated. So that is called the evaporation process. So due to evaporation, what will happen? Water vapor are formed. Water vapor possesses a lower density, so it will go to upper side and it will come into contact with the inner side of the glass cover. It will come into contact with the inner side of the glass cover, and now the inner side of glass cover is somewhat cool as compared with the outside of the glass cover. Hence, whatever water vapor is there, so the phase change will be there, and the water vapor is converted into the water droplets. Water vapor is converted into the water droplets, and due to the angle of the glass cover, the water droplets will be trickled down and it will collected by the distillate trough. it will collected by the distillate rock, and whatever water that is obtained from the solar steel after the evaporation and condensation process, it is called a potable water. Please understand very well. I am asking you, from the solar steel, the water which we will obtain, that's called a potable water. That is not called mineral water. But yes, it is possible that if you will add some minerals to convert the potable that water which is obtained from the solar steel, so it is possible that that water can be converted into the mineral water. So this is the working of the solar out. Actually, why we are working on the solar steel or solar desalination system? So as we all are knowing that whenever something has a drawback, then it is the duty for the researcher to work. Okay, so actually from the solar steel there are drawbacks. There are many drawbacks, but from the easy understanding, I have put only the 5 drawbacks. So from these 5 drawbacks, you can easily understand about the drawbacks. The first drawback of the solar steel, that is a
Hitesh sir, your audio is it's not audible. શું થયું અમને? Yeah, dear participants, there has been a power failure on Dr. Hitesh Panchal's side. He will join us soon. That's what he has said. So we will wait for him. Right? He'll take a couple of minutes to join. So please be with us and cooperate. Thank you. Yeah, good afternoon, participants. There are certain instructions that needs to be given to you. Tomorrow will be the last day of our 1 week online faculty development program. So for tomorrow, we have 3 sessions, right? But tomorrow morning, right, at 10 a.m., we will be putting the link for your test, your evaluation test. and that link will be valid for 24 hours. That means the evaluation test link will be there on will be there from 10 o'clock Friday morning, and it will remain open till 10 o'clock Saturday morning. So all the participants are requested to attempt that test because that is a compulsory criteria for completing this training program, right? Second thing is the feedback. All the participants are requested to go to their Atal portal once the training program is over, and there they will get a feedback from Atal, AICT Atal feedback. That is also one compulsory thing that all the participants need to fill in and submit, right, for their training program to be considered complete, right? So two things you have to do is tomorrow evaluation test. It will be open for 24 hours. You have to attempt that test, right? And second, once the training program is over, then you go to your Atal portal and submit the feedback, Atal feedback there, right? Based on these two things, your certificate, your issuance of the certificate will depend. Your certificate will, you will be able to download your certificate from your Atal portal only, right? So these are the few things that the participants need to take into account, right? I will be again repeating these things tomorrow also, but this is just for your information. Since we have time in between in between this session, I'm discussing this with you. R.D. Patel sir, would you like to say?
No, I think Anurag, you cover all these things. All the participants are requested to follow the as per the Anurag sir's notes. So please fill the evaluation test, and this evaluation test is open for 24 hours. So please, it is compulsory for the Atal FDP, and another thing is feedback, Atal feedback, and third one is attendance. So three major criteria for the certification by AICT Atal. So all the participants are requested to do needful same as. Thank you, sir. And tomorrow is our last session. First session by me, and in second half, Professor Dr. Pratap C. Desai, the president of IST, he will be deliver the lecture on energy. So please, all the faculty members and participants are requested to remain present during this session. Thank you, sir. Thank you.
Sorry, sir. Actually, I was disconnected due to light problem. Actually, there is a heavy rain is
No
falling.
problem, sir. No
Okay.
problem, sir.
Thank you, sir. So from here, I will start. So now next, that is called what are the different factors that affect the performance of the solar steel. So there are many factors, but for the easy understanding, I have taken only four different factors. The factors are glass cover thickness, then depth of water, then area of absorption and cooling of the glass cover. Now, what is the effect of glass cover thickness? So actually, whenever I was starting my PhD, at the same time, I have seen many research articles that have been published by many researchers. So in that research publication, I have seen variation in the glass cover thickness. Some have used 4 mm, some have used 8 mm, 6 mm, etc. etc. But actually, the effect of glass cover thickness on performance on solar steel that has been still unattended at that time. That's why in first experiment, I have taken three similar size solar steel with the variation in the glass cover thickness called 4 mm, 5 mm, and 6 mm. Okay, and 6 months experiment I have conducted. So from that 6 months experiment, I came to know that whenever the glass cover thickness is lower, so at the same time the distillate output will be more. The reason behind it, whenever the glass cover thickness is lower, so the absorptivity transmissivity product alpha into tau, that will be higher, and the amount of solar energy incident after glass cover, that will be somewhat higher as compared with the 5 mm and 6 mm glass cover thickness. That is why one conclusion that I received from the experiment, that is whenever the glass cover thickness will be lower, so at the same time your output will be more. Then other question is arise in our mind, why 4 mm? Why not 3 mm? Why not 2 mm? Why not 1 mm? So actually in the solar desalination, we can say that the solar energy is incident. So this solar steel will act like a thermal reservoir. Okay, so what will happen due to thermal reservoir? The heat is there. So if I will use glass cover thickness less than 4 mm, so due to higher thermal inertia, the glass cover will be broken. Okay, that is why we can start our experiment for the 4 mm glass cover thickness. So one point that we came to know that whenever the glass cover thickness is lower, so definitely your output will be higher. Okay, so from this experiment, one research article has been published in the IJRER journal, that is the International Journal of Renewable Energy Research, that is the Scopus and indexing. Then next factor, that is called the depth of the water. Okay, so if you will see the research article, so researchers have carry out the research that on the variation in depth of water. So if you will go for lower depth, or you go for the higher depth, so what is the effect on the distillate output? So I have taken one figure from the Dr. G.N. Tiwari sir. Okay, he has published one research article in Desalination Journal, which has a very high impact factor. At present, it has a 9.5 impact factor. So in this research article, he has proved that whenever the glass cover, whenever the depth of the water will be lower, here you can see on the graph that 0.04 to 0.18 meter experiment have been conducted. That is for depth of the water. So from the graph, we can say that whenever depth of the water will be lower, at the same time your distillate output or hourly yield, our yield means distillate output will be higher. Reason is very simple. Whenever the depth of the water will be lower, so the heat carrying capacity by that particular, we can say the solar steel will be lower, and it will release the heat. It will not store the heat. That is why whenever you are going for the experiment on the solar desalination system, so at the same time depth of water will be as low as possible. Third one, that is called area of the absorption. As we all are knowing, that name is called solar steel. That means a device which works on the solar desalination principle. Okay, so in the solar desalination or solar steel, the solar energy is has a major contribution. Okay, so whenever solar energy will be higher, so we can say that your output will be higher. It is a fact. But here, if you will increase the surface area or area of absorption, definitely we will improve the heat transfer rate, and hence the distillate output will be higher. It is therefore one experiment has been conducted. My colleague, that is A. Kabil from the Egypt, he has taken means concave wick type of solar steel, and the major outcome from this research work is that they have increase the area of absorption, and whenever the area of absorption will be higher, so definitely your output will be increased. Fourth and very important, that is called cooling of the glass cover. Why the cooling of the glass cover is required? So my dear friend, whenever you are going to work on solar desalination system, so one fundamental point that you must keep in mind, that your water temperature must be higher and inner glass cover temperature will be lower, and then your distillate output will be higher. Okay. Now, if you want to increase the water temperature, there are many methods. In this lecture, I am going to show you about the various solar collectors. So if you will couple the solar collector, definitely it will supply the hot water, and definitely your output will be improved. But how you will reduce the glass cover temperature? For reduce the glass cover temperature, cooling is required. Okay, that is why I have taken one example of one figure that has been published by a research article, Dr. Arun Kumar sir. Actually, in this research article, they have conducted one experiment without cooling and with cooling, and they have taken two different days. Without cooling, they have taken the experiment of April 1, 2010, and with cooling, they taken the experiment on May 2010. So from this graph, we can say that whenever you will apply cooling, so definitely your output will be higher. That is why we can say that if you will go for the glass cover cooling, definitely your output will be higher. So from these four different points, my conclusion is very simple, that there are many factors which affect the performance of the solar steel, but it is up to you that which factors you will use to improve the distillate output. And one thing is fact, that whenever you want to increase the output, at the same time your water temperature will be higher and inner glass cover temperature will be lower. Now, whatever the factors which I have explained you, so all the factors that has been published by one research article in journal for renewable and sustainable energy review, that is a elsewhere publication journal. At present, it has an impact factor around 12. So whenever you will free and you have a time to research work on desalination, then you are requested to read this article. Your fundamental will be very clear. Now, if you want to work on the solar desalination, at the same time, which instruments that you require, which instrument that you require. So that is why I put this slide. The first slide, so in this slide, you can see there are 6 different figures. The first figure, that is called a pyranometer. What is the use of the pyranometer? The use of the pyranometer is to measure the global solar radiation. Is to measure the global solar radiation. Second, that shows the thermocouple. If you want to measure the glass cover temperature, ambient temperature, water temperature, vapor temperature, etc., so you have to use the thermocouple. And in thermocouples are concerned, there are K type, J type, many types of thermocouples are there. But generally in the solar application, K type and J type of thermocouples are used. Okay. Now, third figure, that shows the data logger. Actually, what is the purpose of data logger? So in solar desalination or any solar thermal application, you have to collect the data at every hour or every minute. So it is simply not possible to go to the a place where you will install the solar desalination system and collect the temperature, solar intensity, etc. But if you will use the data logger, okay, there are 8 channel data logger is there, 6 channels is there, 12 channel is there. Okay, so if you use data logger, so data logger will collect the data and it will send that data to the laptop or computer. So it is very important device. So during my PhD work, I receive a grant from Kuchko. So at the same time, I have purchased the data logger. Now, in the solar desalination system, the wind velocity has also effect. That is why one type of anemometer can be used. Okay. Now, in the solar desalination system, your depth of the water that should be remains constant. Suppose if you are working in the desalination system, and in this system, your aim is to see the effect of water depth on the distillate output of solar steel. So you have to maintain the constant depth of water. Okay, so to maintain the constant depth of water, one level control is required. One level controller is required. That is why here the fifth figure that I have put, that is called the level controller, that will maintain the constant level of water. How it works? So working is very simple. Whenever the depth of the water will be decreased as compared with the predetermined level. So what will happen? Float valve will be open and water will be flow to the solar steel basin. And whenever the level will be reached, so at the same time, the float valve will be go to upper side and the water inlet will be stopped. So this is a simple working of the level controller. And to collect the amount of water per hour, I have to use the beaker. So it is called a calibrated flask or beaker to collect the water. So these are the different instruments which we can use whenever we want the research work on the solar steel or solar desalination. Now, our next point, that is called research and developments on solar steel with. So actually, I am a mechanical engineer, and as a mechanical engineer, it is my duty to tell you that whenever you require the higher heat transfer, okay, so the fin is a very cheap and available, you can say that, alternative. Okay, the function of fin is to increase the heat transfer rate. That we very simple, and there are many types of fins are there, like we can say that rectangular fin, okay, plane fin, annular fin, etc., etc. Now, as we all are knowing, in the IC engine, that is called internal combustion engine, suppose I will take an example of a bike. So in bike, the water is not used for the cooling purpose, but fins are there for the air cooling purpose. So the fin has a very good, we can say, advantage. Okay, and it is also for the extended surfaces, and generally it is used for the heat transfer, increase the heat transfer. So first experiment on the fin, that is a vertical and inclined fins with the solar steel. Here you can see I have put one line diagram as well as the experimental setup. Okay, in this experiment, three identical solar steel has been taken. One is a conventional solar steel, one with we can say that fin type of solar steel, that is called vertical fins, and third one, that is called the inclined type of fins. Now, why I have put the vertical and inclined fins? So as we all are knowing, whenever we will use the fins, the fins will increase the heat transfer rate, and definitely your the output will be higher. Okay, that's why I have put the vertical fins. But why inclined fins have been used? Because whenever the fin is a straight, we can say that direction. So at the same time, we can say that whenever solar intensity will be there, so it will create shadow effect on water. It will create the shadow effect on the water. That is why if you will use the inclined type of fin, so the shadow effect will be lower. That is why I have put the inclined type of fin. And from this research work, I came to know that whenever I will use the fins, so definitely the heat transfer rate as well as the distillate output will be higher as compared with the conventional solar steel. But there is no much difference in the distillate output is observed between the vertical fin and inclined fin. Okay, because whenever I will use the inclined fin, okay, it will not significantly improve the, we can say, the distillate output, because here the inclined fin has lower shadow effect. That is why the distillate output is not increased, okay, as compared with the vertical fins. So this was the conclusion of my research work on the vertical and inclined fins with the. Then second one, that is a pyramid type of solar steel with the hollow circular fins. So actually in the solar steel, there are various types of solar steels are there. A single slope, double slope pyramid type of solar steel. Now in pyramid type of solar steel, what will happen? Your condensation area will be improved. Your condensation area will be improved. So definitely the output will be higher as compared with the conventional single slope, single basin solar steel in case of the pyramid type of solar steel. So the research work has been conducted by my friend from the Egypt, Dr. A. Kabil. They have used hollow circular fins, and that fins attach in the basin of the solar steel, and they use three type of solar steel. First solar steel, that is called conventional solar steel. Second solar steel with the hollow cylindrical fins, and third solar steel with hollow cylindrical fins with the phase change material. So from this experiment, they came to know that whenever the pyramid type of solar steel is used with fins plus, we can say that PCM, that is a phase change material, the distillate output will be high. Now let me share why. Now, whenever you will use the fins, so definitely your surface area of water will be increased, as well as the preheating time the water is increased. Okay, but if you will use PCM, that is called phase change material. The phase change material is used to increase the distillate output not only during the sunshine hours, that is called morning 9 a.m. to 5 p.m., but also it can work or it can increase the temperature after 2 hours of the sunshine. That means you will also obtain distillate output after 5 p.m. That is called 6 p.m. and 7 p.m. It is also possible. Because why you will obtain the distillate output? Because here whatever the heat that is stored by the solar steel, so some of the heat is also transferred to the PCM, that's called phase change material, and whenever the PCM temperature is reached up to its melting point, so what will happen? That PCM will be melt and it will release its heat to the water. So definitely this is a very good combination, that you have to use a fins plus the PCM, that's for phase change material, and your output will be higher as compared with the conventional type of the pyramid solar steel. So this is very good experiment on the pyramid type of solar steel with the hollow circular fins. And now why hollow circular fins? Okay, suppose I will use the hollow circular fins and solid fins. So hollow circular fins will improve the output, because the hollow circular fins, there is a hollow portion. So in hollow portion, what will happen? Some of the hot water in the solar steel will be stored, and this water will release the heat during the off sunshine hours. That is why the output will be improved. That is why we can say that if you want to carry out the research work in the solar steel, the fins, so the hollow circular fins, that is a good outcome. You can use. So definitely your output will be improved. Now, third experiment, that is between fin type of solar steel, corrugated solar steel, and conventional solar steel. Now, in the figure, you can see that there are three different solar steel have been fabricated. The area is 1 square meter. Okay, the length is around 2 meter, and the width, that is called 0.5. So if you multiply, so definitely your area will be the 1 meter square. So in this experimental setup, you can see first solar steel, that is called fin type of solar steel, second one conventional, and third one corrugated. Corrugated, very simple fundamental. I think we all are knowing, like a roof. Okay, so metal, so the roof material, that is called GI sheet, and that is called the corrugated material or corrugated sheet. And now if you will use the corrugated absorber plate or corrugated type of solar steel, so definitely your surface area will be increased and your output will be also increased. That is why there is a comparison between a fin type of and corrugated solar steel with the conventional solar steel. This experiment has been performed at Egypt. So from this research work, what I came to know that from this research work I came to know that fin type of solar steel and corrugated solar steel have improved the distillate output. Okay, friend. Now let us go ahead. This is my experiment that currently one of my student is doing PhD in Gujarat Technological University. In this work, you can see the solar steel is attached with the evacuator tubes and fins. Okay, what is evacuator tubes? I will explain you later on. That is one kind of solar collector that will supply the hot water in the solar steel. Okay, so here what I have done, I have used the evacuated tubes, that will supply the hot water, and for the condensation increment, I have used zigzag type of condenser. So the water temperature will be increased. 1 minute, friend. Okay, friend. So this is a very simple work in which the water temperature will be increased with the help of the evacuated tubes, and the condensation that is improved with the help of the condenser. And this is a base combination, and I have obtained around 6 liter of water from the this kind of configuration.
Hitesh sir.
So from this research work here, you can see two research articles are there. Okay, first one that has been published in the Groundwater in Sustainable Development, that is the Scopus Indexing Journal of the elsewhere, and second article you have seen one of my research work. So here, the second article that has been published in the case studies in the thermal engineering, it is a very good journal of the elsewhere, and there's an impact factor around 4.8 around. Okay, so friend, here whatever I have shared with you, it is whole knowledge that is regarding with the solar steel or solar desalination with the fins. Now let me go ahead. Now, if you want to carry out the research work, okay, on solar steel with fins, so here I have put some of the my ideas that you can use the truncated type of hollow fins. Okay, I think fins that you have seen earlier, but truncated type of hollow fins have not used by the researcher till today. Okay, so if you will use the truncated type of hollow fins, so definitely your distillate output will be increased. Okay, and you can compare the output with the conventional type of solar steel. Then second one, you can also use the hollow fins with the latent heat storage materials. Okay, and such kind of combination is still not used by the researcher. Suppose if you will use the hollow fins, and if you will fill that hollow fins with the latent heat storage material, so what will happen? Whenever the temperature of the latent heat storage material will be reached up to its melting point, definitely it will release the heat to the water, and your temperature of water will be increased. And definitely, as per the fundamental knowledge of the solar steel, whenever the temperature of water will be increased, so definitely your output will be increased. So this is also a very good point, that you can use the hollow fins with the latent heat storage material. And third one, that at present none of the researchers have worked on the optimum number and size of the fins. Okay, yeah, that which kind of fins optimum size as well as the optimum numbers, that still not used or still not researched by the researchers. So these are the different points that you can use if you want to carry out the research work on the solar steel with the next portion, that is the research and development on solar steel with the storage material. Okay, so friend, here storage material, here I am not going to say you about the latent heat storage material, but I am going to explain you about the sensible heat storage material. Sensible heat storage material means what? Means phase change will not occur. Phase change will not occur. That's why it is called the sensible heat storage material. Now, before starting the explanation, first of all, it is my duty to explain you why the heat storage materials are required in solar steel. So, friend, as we all are knowing, in case of solar steel, the solar energy is incident, okay, and water will be evaporated, and then condensation process is done, and then you will obtain a distillate output. That means whole process that depends on the solar energy. Okay, so and also we all are knowing that at 12 p.m. your solar intensity will be highest. That means you must obtain the highest distillate output at 12 p.m. Okay, but as per the research, we cannot say that you will receive the highest distillate output at 12 p.m. but you will obtain the highest distillate output after 12 p.m. means near about 1 p.m. Okay, what is the reason? So, dear friend, at 12 p.m., the solar intensity will be higher. Okay, so we can say that due to the incident of the higher solar intensity, the temperature of water will be higher at 12 p.m. Okay, so this higher water temperature will form a water vapor at a high temperature. Such high temperature water vapor will go to the upper side, and then it will come into contact. Then it will be come into contact with the inner side of the glass cover, and it will increase the temperature of the inner side glass cover. Okay, so whenever temperature of glass cover will be increased, that means your condensation will be decreased. So this is the reason why you will never obtain highest distillate output at 12 p.m. Okay, so what is the remedy? The remedy is, if you will use the sensible heat storage material or storage material, so such storage material will store the excess of heat it will absorb the excess of heat during the sunshine hours, and it will release such heat during the off sunshine hours. That is why the research has been done and it is going on heat storage material in solar steel. This is my first experiment. In this experiment, I have not used the storage material, but I have used aluminum plate. I have used aluminum plate. Actually, why I have put the aluminum plate? So what I have thinking at the same time, the solar energy will be incident on the glass cover, then it will go to the basin where water is poured. Okay, but if I will reduce the path that is traveled by the sun rays, and I will use one plate just below the upper level of water, and then also I will put some gap. So what will happen whenever solar energy will be incident on that plate? Okay, so temperature will be increased, and also minimum amount of water is there above that plate. And earlier we have already studied that whenever the water depth will be lower, so at the same time your distillate output will be higher, and excess of heat that will go to the lower side of that plate, and that heat will be stored by the brackish water. And during the off sunshine hour, what will happen? Whatever heat that is stored, that will be released. That is why you can see that here two zones are formed. First is called the evaporation zone or evaporating zone, and second one that is called the heat storage zone. So this is a very simple method to increase the distillate output of water with the help of the folded, we can say that aluminum plate. So from this research work, I came to know that around 15% increment is obtained by the this kind of arrangement. Okay, so very simple experiment that I have conducted, and from this research work, I have published one research article in Indian publication journal, that is a International Journal of Energy and Environmental Engineering. Okay. Now, second experiment that has been conducted by me, in which I have put three similar size of solar steel, in which first solar steel is considered as a conventional type of solar steel. Second solar steel is filled with the marble pieces, and third solar steel used with the sandstones. With the sandstones, marble pieces and sandstones are easily available. So we are not we can say pay any money to any person, because they are easily available. And this experiment has been conducted for the 6 months of time interval. And from this experiment, I came to know that marble pieces and sandstones found higher distillate output as compared with the conventional solar steel. But if I will compare the distillate output of marble pieces and sandstones, so I receive higher distillate output, okay, for we can say that sandstones as compared with the marble pieces. You can see a figure in which you can see the cumulative distillate output. The highest cumulative distillate output is obtained for the sandstones. So what is the reason? The reason is a sandstone, that is a we can say the sensible heat storage material, and it is also a porous material. Okay, it's also a porous material, and due to pore holes, some of the water is stored, and definitely your output has been improved. So from this experiment, I came to know that sandstones is a very good material, and definitely you can improve the distillate output by use of the sandstones in the solar steel. Now, from this research work, one research article has been published in the International Journal of Ambient Energy. Now, third experiment, that is solar steel with the marbles. I think marbles that all we have seen. Okay. Now, marbles are also considered as sensible heat storage material. So first, one of my students has conducted one experiment with the marbles. He took one vessel with the water, and then he has used marbles. Okay, so from his simple research work, he came to know that the temperature of water is increased with the help of marbles. That is why one experiment has been conducted. Okay, and in this experiment, double slope solar steel has been used. Okay, and the comparison is explained in terms of the cumulative distillate output with and without marbles. So you can see that with marbles your cumulative yield will be increased, but this increment is not 50% or 60% increment. It is around 7 to 10% increment. Okay, but yes, marbles are easily available, so you can use such kind of marbles in solar steel to increase the distillate output. Now, next experiment, that is a solar steel with the quartzite rock as a storage material. Quartzite rock are also easily available. Okay, so in this experiment, you can see that only one solar steel has been used, but the experiment has been conducted with and without quartzite rock, and here 3 days constant trial has been taken, and from this trial. It has been found that the quartzite rock is also a good thermal energy storage material, and it increases the distillate output. Now, whatever the research papers that has been published, so I have also published one review article in Renewable and Sustainable Energy Reviews. In this review article, if you will read, so definitely you come to know that what is energy storage material, especially that is called the sensible heat storage material, what different factors that you can choose whenever you will use the energy storage material. Now, a current research work on storage in solar steel. So actually, in case of solar steel, whatever the research work has been conducted by the researchers, that all have used low thermal conductivity materials. Okay, but at present nobody has used the higher thermal conductivity materials, because whenever you will use the higher thermal conductivity materials, so definitely it will improve the thermal conductivity of water and your output will be enhanced. Okay, but one thing that you must keep in mind, that if you want to use the higher thermal conductivity materials, so it will also increase the bottom losses. That is why your solar steel must be prepared in such a way that the bottom loss will be lower. Okay, and if you will use and if you will prepare solar steel with a good insulation material, and then if you will use the higher thermal conductivity materials, definitely your distillate output will be enhanced. That is why I have put that that researchers are there, so they can also use the higher thermal conductivity materials, and definitely you will obtain the higher distillate output. And also, nobody has used the combination of the sensible and latent heat storage material, because if you will see the research article, that some researchers have used sensible heat storage material, some have used the latent heat storage material, but the combination of the sensible and latent is still unattended by the researchers. Why? Because if I will use the sensible heat storage material, the sensible heat storage material will store the heat, during the sunshine hours. And the latent heat storage material, suppose I will use the low temperature phase change material, okay, like a 50 degrees, that is a melting point. So whenever the 50-degree temperature is reached, so definitely the latent heat storage materials will be used, so it will release the heat. So definitely the temperature rise will be there. So combination that has a very good research work criteria. So definitely if you want to work on the solar desalination system or solar steel, so you can use the combination of the sensible and latent heat storage material, and you can compare the output with the conventional solar steel. Third one, that you can use a different designs of the absorber plate with the higher thermal conductivity materials. Now, as we all are knowing regarding with the absorber plate, okay, absorber plate is always painted black and the water is poured on the absorber plate. Suppose if you will use different designs, like suppose if you will use the corrugated design or fin type of design, okay, half barrel design, such kind of designs if you will apply on the absorber, and if you will use the higher thermal conductivity materials, so what will happen? The higher thermal conductivity materials will increase the thermal conductivity of water, and the design change that also increase the surface area. So the combination of the absorber plate with the higher thermal conductivity materials, definitely your output will be enhanced. Okay, but still today nobody has applied such kind of idea to improve the output of solar steel. And fourth one, that you can also use the different designs of the absorber plate with combination of latent and sensible heat storage material. So these 4 points are there. So suppose if there are some researchers are there, and if they want to carry out research work on the desalination, so they can also see such kind of future work, and they can start their research. Now, the third point, that is the research and development on solar steel with the solar collectors. Now, solar collector, as we all are knowing, that it will collect the solar energy and increase the temperature. That is the simple definition of the solar collector. But we must understand very well why the solar collector coupling required with the solar steel. So answer is very simple. Earlier I have already told you that the distillate output which is obtained from the solar steel, that depends on two parameters. First parameter, that is called higher water temperature in the basin and lower inner glass cover temperature. And if you want to increase the water temperature, so very simple method, that you can couple the solar collector, because the solar collector will supply the hot water into the basin. And whenever the hot water is supplied to the basin, it requires less heat for the evaporation, okay, and definitely your distillate output will be higher. That is why solar collectors have been used by the many researchers to increase the distillate output of solar steel. The first experiment has been performed by the Dr. G.N. Tiwari sir from IIT Delhi during 2009. During this experiment, they have used a flat plate collector, FPC. Okay, flat plate collector is very simple collector. Earlier they have been used by the many researchers. Okay, but the cost is somewhat higher. Okay, so how this system works? So in this system, a flat bed collector has been used, okay, and the water from the basin that will supply to the flat bed collector with the help of the pump. Okay, so you have to require a pump. The pump will supply water towards the flat bed collector. Flatbed collector has a copper tubing or piping. Okay, it will take the sun rays, increase the water temperature. So outlet of flatbed collector that has a higher water temperature as compared with the inlet, and that hot water will go to the basin. Okay, so this cycle will be continued. Okay, so from his experiment at IIT Delhi, they concluded that a maximum distillate output of the solar steel with couple of the flat bed collector is reached up to the 6.75 liter for the month of October. From the month of October. Okay. Now, at present, if you will see the solar collector, suppose if I will take an example of a solar water heater. So nowadays, solar water heater use the evacuated tubes. Use the evacuated tubes. And how these tubes will be worked? So from the working criteria, two figures are shown. First one, that is the real irrigate tubes, and second one, that is a line diagram. From line diagram you can see the cold water. Okay, the cold water will go to the downward side. Okay, it will take the sun rays, and due to thermosiphon effect it will go to the upper side. That means if you will use the evacuated tubes, that's why you don't require any kind of pump, because earlier you have seen in this figure, in flat plate collector a pump is required. Evacuated tubes, no pump is required. Okay, and it is simply work on the thermosiphon principle. That is why at present a solar water heater use the evacuated tubes. Okay, now this is the experiment that has been conducted by me during my PhD. Here you can see one solar steel is there, that is a single slope, single basin solar steel, and it is directly coupled with the evacuated tube. So what will happen? Whatever water is there in the basin, that is a cold water. The cold water will go to downward side. That's called the evacuated tubes. It will take the solar energy and become hot water, and due to thermosiphon effect, it will go to upper side, and then it will go to the basin. And whatever cold water is there, further it will go to downward side, and this cycle will be continued. Okay, so what is the peculiar property of this setup is that here first you don't require any kind of pump. Okay, second one, the tubes are directly coupled. Okay, so no, we can say the coupling is required. Okay, suppose in case of flat plate collector you have to use the coupling, and that coupling you have to couple with the solar steel, but here you don't require any kind of the coupling. Okay. Now this is the setup of the solar steel with the evacuated tubes. Okay, and from this research work, one research article has been published in the Heat and Mass Transfer Journal, that is a SCIE journal. Okay, and in this journal I have conducted the theoretical analysis as well as the experimental analysis, and compare the theoretical and experimental results, and I receive very good agreement between the theoretical and experimental results. Now next experiment, that is a pyramid type of solar steel with the evacuated tubes. So here you can see, okay, the pyramid type of solar steel. Why the people have used the pyramid type of solar steel? Because the condensation area that is improved or increased with the help of the pyramid type of solar steel. So here you can see the 6 tubes are there that is directly coupled with the pyramid type of solar steel, and it is compared with the conventional solar steel and conventional pyramid type of solar steel. So from this experiment I came to know that whenever you will attach the evacuate tubes, okay, with the pyramid type of solar steel, definitely it will supply the hot water and your distillate output will be increased. Second one, earlier I have shown you that this is called a single basin solar steel. Then I have conducted one experiment with the double basin solar steel. So why the double basin that I have used? So in double basin solar steel, what will happen? Whatever the heat that is lost to the atmosphere from lower basin, so that heat will be utilized to increase the water temperature of the upper basin also, and upper basin will receive the sun rays also. Okay, so this is a very good combination that from the single solar steel you will obtain the distillate output from the upper basin and lower basin both. Okay, that is why I have also conducted one experiment with the double basin solar steel. This is the dimension of the double basin solar steel. This is the experimental setup of the double basin solar steel with the evacuator of vacuum tubes. The working is very simple. Okay, the upper and lower basin is filled with the water. Okay, in lower basin, whatever the vacuum tubes or evacuator tubes are coupled, so the cold water will go to downward side of the evacuate tubes. It takes the sun rays, become hot water, and due to thermosiphon effect, the hot water will go to the basin. Okay, now whenever the water is formed from the lower basin, so some heat is lost to the atmosphere. Okay, but here instead of atmosphere, we have attached one more solar steel. Okay, so that heat will utilize to increase the temperature of the upper basin, and upper basin also receive the sun rays. Okay, so from this design you will obtain the distillate output from lower basin as well as upper basin both. That is why from this kind of solar steel around 10 liters of water is possible. Suppose if I will take one problem definition that I require a solar steel for a small family, like 2 adults, 2 children. Okay, so this design is better because as per the WHO guidelines, okay, one adult can drink average of 3 liter water per day. Okay, and a child will be half that. That's called 1.5 liter. So if I will consider 2 adults and 2 children, that in total consumption will be 9 liters. Okay, and these double basin solar steel with vacuum tubes, the average distillate output is obtained around 10 liters. Okay, and the energy payback time of this system is less than 1 year. Okay, that means after one year, whatever money that you have spent, you will get it rebate. So this is a very good design for the double basin solar steel with the vacuum tubes, and distillate output is obtained around 10 liters water per day. Okay. And from the double basin solar steel, one experimentation has been conducted, and the experimental results, whatever obtained, that has been published by the Journal of King South University. That's the Elsevier Publication Journal, and one more research article has been published in Desalination Water Treatment Journal, that is the SCIE Journal of the Taylor and Francis. Then I have also conducted one more experiment, that is a triple basin solar steel. Okay, first I have conducted with the single basin, then double basin, and then triple basin. And in triple basin, instead of the single or the simple absorber plate, I have used the corrugated design, and instead of the vacuum tubes, I have utilized the evacuated heat pipes. Okay, so how it works? So the heat pipe will heat the water. Okay, so temperature of water in the lowest basin will be rise, and you will obtain distillate output, and whatever heat will be lost from the lower basin, it will utilize to increase the temperature of the middle basin. The middle basin will take the heat from the lower basin, and it will increase its temperature, and the distillate output will be obtained, and whatever heat that is lost from the lower basin, it will utilize to increase the temperature of the upper basin, and upper basin is directly come into contact with the sun rays. Okay, so it will obtain a sun rays directly. So from this design, you will obtain the distilled output from three different sources called lower basin, middle basin, and upper basin. And total distilled output is obtained around 15 to 17 liters per day. So this is the best design. And the total fabrication cost of this solar steel is around 25,000 to 30,000 rupees, and we can say that the distillate output per day is around 15 to 17 liters. So this is very good design of the solar steel. Okay, that's for the triple basin solar steel with the vacuum tube. So first I have shown you a single basin solar steel with vacuum tube. That second one called a double basin solar steel with vacuum tube, and third one triple basin solar steel with the vacuum. Now, from these evacuate tubes research work, okay, one article has been published in Groundwater for Sustainable Development. Article has been published by me, in which I have used a single slope, single basin solar steel with calcium stones, that is called the sensible heat storage material. Okay, and this article has been published in Process Safety and Environmental Protection Journal. That's a elsewhere publication journal, and it is an impact factor more than 6. Now, after the flat plate, then infrared tubes, some researchers have also used solar steel with the parabolic trough collector. Okay. Now, what is a parabolic trough collector? The parabolic trough collector, that is a collector in which you can see the parabola shape, and the middle you will obtain the concentrated tubes, okay, or receiver tubes. So whenever the sun rays will be incident on the parabola shape, so those such rays will be reflected towards the receiver tube. And receiver tube, suppose if you will supply the hot water or heat transfer fluid, definitely the temperature of water or heat transfer fluid will be raised. Now, how this system works? So you can see one oil tank is there. From this oil tank, one pump is put. So the whenever pump will be operated, so the oil will be supplied into the receiver tube. Receiver tube will receive the sun rays, okay, and it will increase the temperature. So the oil will be possess the high temperature, and the high temperature oil that will go to the solar steel. Now in solar steel, that is a zigzag type of connection, that's called a heat exchanger. So that is passing through the heat exchanger, okay, and then further it will go to the oil tank. So whenever the oil is passing through the heat exchanger, okay, and if you will pour a water, okay, so water will take the heat, okay, and the temperature of water will be increased. So this is a basic principle how the parabolic trough collector is used to increase the distillate output of the solar steel. This experiment has been performed by the Dr. A. Kabil sir at Egypt, and around 7 to 8 liter water is possible to obtain from the parabolic trough collector whenever it is coupled with the solar. Also some photographs in which you can see a line diagram of the solar steel. In this solar steel, it is somewhat modified, because in simple solar steel only absorber plate is there, that is painted black. But here absorber plate is there, but here one more thing, that is called the heat exchanger is attached. Okay. Second experiment, that is also with the parabolic trough collector, in which the heat transfer fluid is not used, but the water from the solar steel that is directly passing through the parabolic trough collector. It will take the sun rays and increase its temperature. But here in this figure, one pump is not shown, because of water cannot directly passing through the parabolic trough. Okay, so the cost of such kind of system will be higher as compared with the solar steel coupled with the evacuate tubes. Okay, so friend, you have seen that there are two types of design. In first design, the parabolic trough collector use the heat transfer fluid, okay, and second design parabolic trough collector use the water, okay. But from in both the cases, the distillate output will be higher in case of the solar steel coupled with the flat plate. Solar steel is coupled with the parabolic trough collector and heat transfer fluid. Now, if you want to carry out the research work on the evacuated tubes collected with the solar steel, so here 4 points I have put. First point, that is called you can also carry out research work on the evacuated tubes with the solar steel integrated with fins. Fins that we have studied. That fins will increase surface area and also the preheating time of water. But nobody still is applied their mind to use the fins in the solar steel that is coupled with the evacuated tubes, because if you will use the fins with the evacuated tubes, so definitely your surface area will be increased and the water temperature will also increase, and definitely your output will be increased. Second one, you can also use the evacuated tubes with the solar steel and condenser. Okay, earlier already I have shown you one picture in which I have used a solar steel with the evacuated tubes and condenser. Why this combination? Because if you will use the evacuated tubes, so it will supply hot water, so temperature of water will be increased, okay. And if you use the condenser, the condenser will increase the condensation, okay. So your temperature of the inner glass cover temperature will be lower, and higher water temperature and lower inner glass cover temperature will increase the distillate output. That is why this is a good concept through which you can carry out the research work, and definitely your distillate output will be higher. Okay. Third one, that is a solar steel with the sensible heat storage material in evacuated tube. So earlier already I have shown you one experiment in which the solar steel is coupled with the evacuated tubes and sensible heat storage material, because sensible heat storage material will absorb the excess of solar heat during the sunshine hours, and it will release during the off sunshine hours. And fourth and very important, that you can also carry out research work on the solar steel that is coupled with the evacuated tubes and sensible and latent heat storage material. This kind of combination is still unattended by the researcher. So definitely friend, if you want to carry out research work, so these are the 4 points that such points you can directly apply, and definitely your distillate output will be increased, and your it is also a chance that you can publish a research article in Scopus or SCIE indexed journals. Now, next portion, that is the research and development on solar steel with the HDH. That's called the humidification and dehumidification system. Now, friend, this system is somewhat new. That's called the humidification and dehumidification system. But for the simple knowledge, if I can explain, though, I can say that whatever water that is produced by the air conditioning system, that is nothing but that is called the dehumidifier. Okay, and this whole system, it is called the humidification and dehumidification system. Okay, this is a diagram, but before starting the HDS system, let me share with you why the HDS system is required. So dear friend, from the research work conducted by many researchers, one point that keep in mind that in the solar steel it is also possible to increase the output, but it is possible up to 20 to 25 liter. Okay, because there is one limit. Okay, so you cannot go for above 25 liter water. Okay, but this HDS system, that's called the humidification and dehumidification system, has a potential that it is possible to increase distillate output not from the 50 liter but also 500 liter to 5000 liter. So it is my duty to share some knowledge regarding with the humidification and dehumidification system with the solar steel. Now, how this HDS system is work? So you can see that the dry air from the sun that is passing to the solar collector, but here solar collector, that is a solar air heater, not the solar water heater. Okay, that is a solar air heater. So whenever air is passing to solar air heater, become the hot air. This hot air will passing through the humidifier. Okay, and in humidifier, okay, it will be humid air is there, and this humid air is passing through the dehumidifier. Okay, and in dehumidifier, there is a one heat exchanger is there. So if you will apply the cold water is flowing, and it will absorb the heat, and the dehumidification will be there, and from the warm humid air you will obtain the water droplet. So this is a function of the humidification and dehumidification system, and this system require two important devices are called the humidifier and dehumidifier. Okay. Now this is the line diagram and experimental setup of the solar HDH desalination system. In this system, you can see that the humidifier is there. Okay, it will supply the humid air to the dehumidifier, and in dehumidifier the water is obtained. This is a line diagram of the humidifier. Now, this is a figure of the flash evaporation and condensation system. Now, in this system, you can see SWH1 and SWH2. That's called solar water heater 1 and solar water heater 2. After passing to water by SWH1 and 2, that water will go to the flash chamber. In flash chamber, whenever it will be passing, so it will create a two-phase mixture, partial water and partial steam. And steam possesses low density, so that low density steam that will go to a condenser, and in condenser the condensation process is there, and definitely the distillate output will be obtained. So this is a diagram of the flash evaporation and condensation system. Now if I will combine the HDS system and second one, that is called the flash evaporation and condensation system, so that's called the hybrid desalination system. And this whole system, that is a combination of two different systems. That's why it is called a hybrid system. And this system has been designed to obtain distillate output around 50 liter water per day. 50 liter water per day. And this is the experimental setup of the hybrid solar desalination system. Here you have seen, this is a line diagram. These all are the components. You can see the solar water heater, a flash chamber is there, steam condenser is there, okay, vacuum pump is there, okay. In the flash chamber as well as the steam condenser are very important devices, okay. This is a yield that is called the distillate output analysis of the hybrid desalination system, that you can see the combination of solar steel, single stage flash and HDS system, so that the distillate output is obtained around 50 liter water per day. Now from this research work, one research article has been published by the myself and my group, okay, Kishore Kumar sir, Ramanna sir, okay, Suresh sir, Israr sir, Mohammed, Eklavi sir, Hagar ma'am, okay, and this paper has been published in the International Journal of Ambient Energy. And the whole system that I have combined into a small system. So I have prepared one setup that is called the HDS system, called the humidification and dehumidification system. Okay, if you will attach the solar water heater and solar air heater, so that the whole system is converted into the solar HDS system. At present, that is the only HDS system, and from this system I have applied for the industrial design, and the industrial design has been granted. So you can see the grant certificate from the patent office. Now, what are the current research works on the HDH system integrated with the solar desalination system? So first of all, it is also possible that the integration of the HDH system with the solar steam and single and double flash chamber. Okay, so friend, the single stage flash chamber already I have used. Okay, but the double stage flash chamber is still unattended by the researcher, and it is also possible that this whole system can be converted into a 50 liter to the 500 liter with the help of the double stage flash chamber and certain modification in the design. And second one, it is also possible that this system can be combined with the solar dryer, because from this system the whatever the air will be lost, so such air can be utilized in the solar dryer for the drying purpose. So there are only two points that I can discuss as a current research works on the HDH system. Now last one, that is second last, that is called research and developments on solar steel with the nanomaterial. So dear friend, nano materials that we all are knowing, if you are from civil, mechanical or any branch, okay, so nano materials are very important. And here this diagram, what diagram, this is a table that shows the various nano powders that has been used for the solar desalination system. But first of all, we must understand very well what is the use of the nanomaterials. So dear friend, whenever you will use the nanomaterials in the solar desalination system, so the nanomaterials will improve the thermal conductivity of water. That will improve the thermal conductivity of water, and definitely it will increase the distillate output. That is why many researchers have applied their mind to carry out the research work on the solar steel with the application of the nanomaterials. Okay? Are the certain nano materials that has been used by the researchers in the desalination system, like the aluminum oxide, zinc oxide, tin oxide, iron oxide, gold nanopowder, titanium oxide, copper oxide, carbon nanotube, zirconium oxide, silicon nitride, boron nitride, aluminum nitride, diamond nanopowder, silver nanopowder, etc., etc. Now in these all the nano powders, as a researcher, we must understand that the cost will be as low as possible. Okay, so from this figure you can see the lowest. We can say that the price is, it is around 1,500 for the zinc oxide. Now I have conducted one experiment. In this experiment, I have taken three nano materials: zinc oxide, lead oxide, and aluminum oxide. Okay, and from this research work, I came to know that the aluminum oxide nanofluid that possess a higher distillate output as compared with the zinc oxide and SN2. Okay, the reason is very simple. The thermal conductivity of Al2O3 will be higher as compared with the zinc oxide and SN2. This is also an experiment that is conducted for solar steel with the condenser and nano fluid. Actually, the basic idea of this kind of experimentation is, earlier we have discussed that higher water temperature that will increase the output, and the lower inner glass cover temperature also increase the distillate output. So if you will use the nano fluid, okay, and mix with the water, and if you will pour such kind of fluid in the solar steel, and if you will use a modification in the design, so definitely your surface area will be increased, and due to use of the nanofluid, thermal conductivity will be increased. So temperature of water will be increased. And if you will use the condenser, so condenser will reduce the inner glass cover temperature, and your distillate output will be improved. So basic aim of this research work is to increase the distillate output by increase the water temperature and reduce the inner glass cover temperature. That is why this experiment has been conducted by Dr. A. Kabil sir in climate condition of Egypt. Second experiment, that is a pyramid type of solar steel with the nanofluid. Okay, earlier already I have shown you what is the pyramid type of solar steel. Okay, and here the comparison has been carried out between the pyramid type of solar steel and the we can say single slope solar steel. So from this research work, it is calculated that if you will carry out the research work on the nanofluid on pyramid type of solar steel, definitely your distillate output will be higher. And from this research work, okay, one research article has been published by my team in Journal of Cleaner Production. It is a very good international journal, and it has an impact factor at present above 9. Okay, so this article has been published. This is the second article in which solar steel with copper oxide nanofluid and graphite nanoparticles. Okay, so here you can see three similar size of solar steel has been used. Okay, and second and third solar steel is used with the copper oxide nanofluid, and third one with the graphite nanoparticles. Okay, so from this research work we come to know that the higher distillate output is obtained with the solar steel with the graphite, because graphite has a higher thermal conductivity, graphite nanoparticle. Okay, so that is the reason why the distillate output will be higher for the graphite nanoparticles in solar steel. The third research work that has been completed by Dr. G.N. Tiwari sir, in which they have used flat plate collector, okay, and the flat plate collector is coupled with the double slope solar steel with use of the heat exchanger, and they have also used the nanoparticles. Okay, so the distillate output will be always higher if you will use the flat plate collector with the nanoparticles. Okay. This is also one good research work has been conducted by Dr. E. Kabil sir, in which they have used nanoparticles, okay, or nanofluids in solar steel, and also they apply the vacuum. Okay. Now one question arises in our mind: why the vacuum is used? So dear friend, very simple fundamental. Okay, that whenever you will apply vacuum, okay, so it is also possible to evaporate the water at a low temperature, to evaporate water at a low temperature. That is why if you use vacuum, so it is also possible that you can increase the temperature at low temperature, and also you can produce the water vapor at low temperature. That is why vacuum has been used. So the combination of vacuum with nanofluids as well as condenser, definitely it will increase the distillate out, because vacuum and nanofluids will increase the water temperature, and a condenser will reduce the inner glass cover temperature, and higher water temperature and lower inner glass cover temperature increase the distillate out. This is the research work that has been conducted by me. Okay, in this research work, I have taken two similar type of solar steel. One is the conventional, and second one that is a modified solar steel. But in modified solar steel, I have mixed percentage of the manganese oxide nanoparticles and mixed with the black paint, and painted on the absorber plate as well as the side covers. Okay, so what will happen if you will mix manganese oxide nanoparticles with a paint, and then you will apply painting on the walls as well as the absorber plate, definitely it will absorb more heat, and it will increase the temperature. So definitely you will improve the distillate output with the help of mixing of nanoparticles with the black paint. And that is why you can see one graph is there. From this graph you can see the distillate output will be higher for the modified type of solar steel as compared with the conventional solar steel. And from this research work, one article has been published in the case studies in thermal engineering journal, that is a reputed international journal of elsewhere, which has a quarantine of Q1, and impact factor is around 4.8. Okay, so whenever if you want to carry out some research work on nanoparticles on solar steel, you can see the research paper, and definitely you will understand, and definitely you can carry out the research work on the solar steel, that mixing of nanoparticles and black. Now, what are the future research works? So friend, actually I have published one review article in Iceland journal, but at present the proof is not available. Otherwise, all the notations already I have written that the overall productivity enhancement by the nanoparticle should be examined for different climate zones to achieve a more comprehensive data about the technique. Because suppose I have used the solar steel at Patan, that Dr. Kabil has used the solar steel at Egypt, Dr. Kishore has used solar steel at Qatar. Okay, but the comprehensive data are still missing at present. Second one, long-term operational stability and cycle and life cycle assessment are critical issues. Okay, because nobody have applied any research articles on the on the long-time operational stability and life cycle assessment of the nanoparticles in solar desalination system. Third one, conduction of numerical and mathematical modeling and obtaining some correlation for estimation of productivity and heat transfer coefficient are still unattended by the researchers. And last one, the mostly research works have been done on single and double stroke solar steel, but there are also some different type of solar steels are there. That is called sun tracking solar steel, semi-sphere solar steel, cascade type of solar steel. Okay, we can say that tubular solar steel. So such solar steel are already available, but still research have not done. And last one point, that is a machine learning application on the solar steel. Now, if you will see the research articles, okay, so some of the researchers from Egypt, from China, they have published research papers on machine learning application on solar steel. I think somebody know about the machine learning. What is a machine learning? So actually, dear friend, machine learning is a branch of artificial intelligence and computer science which focus on the data, on the use of data and algorithms to imitate the way that human learn, gradually improving its accuracy. Gradually improving its accuracy. Now in machine learning, why one of my research friend from the Egypt, this paper has been published by him. In his research work, they have predicted the performance of tubular solar steel based on the machine learning algorithm that's called a Bayesian optimization algorithm. And here they have used the tubular solar steel. Okay, tubular type of solar steel, and here you can see tubular type of solar steel has a good condensation area. Okay, now in the machine learning, which process that has been followed. So in machine learning process, if you have some data, so you have to input your data. The data will be analyzed by the optimization or algorithm. Then you will obtain the patterns. Okay, and after getting the patterns, you will get the prediction in terms of graphs. In terms of graph, and then you can store and feedback to the particular person. So this is a process that should be followed in the machine learning. In machine learning. Now, earlier this figure that I have shown you, that is this is a tubular solar steel, and I am going and my intention is to explain that how the prediction can be obtained with the help of the type of solar steel. For prediction, first of all, you have to prepare a random forest. What is the meaning of the random forest? The meaning of random forest is a regression and classification problems. Okay, the random forest is only applied for the regression and classification problems, and in the random forest there are many numbers of decision trees. Here you can see the first decision tree, second decision tree, and third decision tree. And then you have to apply your random forest to the artificial neural network. And here 5 input layers are there, 3, 4 temperatures, 1 velocity and one intensity, and output data is only one, that is called distillate output. So after data flow, okay, to use some indicators, okay, like mean absolute error, then mean absolute percentage error, mean square error, and determination coefficient, okay. And for the forecasting, or we can say that for the calculation or prediction result, uh, we must add variables with sample size, maximum value, minimum value, mean value, and standard deviation. Here you can see there are 6 different input variables are there, and total 144 samples have been taken from the each input variables, and each input variables have maximum value, minimum value, mean value, and standard deviation. Okay, all such data are required if you want to work on the machine learning algorithms. Okay, and after applying data, you will obtain some output. So such kind of we can see that graphs that can be obtained from the actual values as well as the predicted value. Suppose if you have actual values are there, actual value you can feed through the software, and earlier whatever the random forest and ANN is there, so from such data you will obtain the predicted values. So you can see the predicted and actual values are there. Okay, so for random forest, the BOA, that is called Bayesian optimization algorithm, RF, then ANN, BOA, ANN, and regression. So 5 different, we can say that graphs will be generated, and here from this graph, that we can predict that there is a close correlation between the predicted values and actual values. Earlier, what the researchers have done, so some of the researchers have carried out the validation with the help of CFD software, or somebody have used on the models. Okay, some models are there, so if you will add the values to the model, so you can get the results in terms of uh, the correlation. Okay. Now from this prediction performance, okay, these are the 5 models. That's called RF, called random forest. ANN, that is called artificial neural network. BOA stands for Bayesian optimization algorithm. Random forest, then BOA, ANN, that's called the Bayesian optimization algorithm, ANN, and MNN. So this is also called a comparison between the same value. That's called the actual and predicted. Okay. And whatever the result that I have shown, so all such results I have taken from the research article that has been published in 2021 by friend Dr. A. Kabil sir. Okay. So friend, this is all about the machine learning. So, whatever research that has been conducted by me, actually during the PhD work, I received a grant from the Gujkost. It was around 5.50 lakh rupees. Okay, and second grant I have received from the scheme of Young Scientists and Technologists, that is the DST. And from this grant, I received 9.55 lakh rupees. Single basin, double basin, triple basin solar steel that has been performed from the grant from the Gujkost, and the HDS system, that's called the humidification and dehumidification system research work that have been conducted from the grant which is available from the SYST, that's called the scheme of Young Scientists and Technologists. Thank you very much. Now, if you have any doubt, then you are requested to ask me question if you have.
Thank you, sir.
Thank you, sir.
There are quite a few questions, sir, from the participants.
Okay, sir.
Yes. One by one, I will take all of them. Okay, Vineet Modi, sir, is asking that can we increase performance of solar still by increasing surface area of collector glass without adding vacuum tube?
Yes, sir, it is possible. But due to such kind of method, the capital cost and the CPL, that's called cost per liter, that will be increased. Earlier, some researchers have applied such idea, but if the capital cost as well as the cost per liter will be increased, so there is no meaning of such kind of research. That is why best option is you use evacuate tubes, okay, instead of earlier.
Okay, sir. Uh, Vineet Modi sir is again asking that what is the difference between distilled water and desalined water?
Look, sir, uh, desaline means what? Suppose I will use the water from the sea, okay, sea, and the sea water is converted into potable water. That's called desalinated water, okay. And suppose I will take water from the tap, okay, tap water, okay, and then I will apply the heating in utensil, okay, and
Right, right, right.
that's called the distillation. This is a basic difference between desalination and distillation. But one thing that you should keep in mind, that this is called potable water. Okay, I think we all are knowing that whatever the water which we will obtain from the rain, that is, it is also called the water that is obtained by the evaporation and condensation. Okay, the same water or same quality of water that will be obtained from the solar steel. And it is also possible that whatever the water you will obtain from the solar steel, that is called the potable water, you can convert such water into the mineral water by adding the minerals. I have also conducted one experiment in which I have concluded that per liter, if you will use by adding the minerals, the cost is around 30 paisa per liter.
Okay, sir. One more question from Dr. Sham Khamborja. Which are the best performing materials for solar panels these days? And with what efficiency?
Sir, actually solar photovoltaic is there. The base material that we all are knowing, that's a silicon. But at present, there are many materials are there. Okay, but such materials have been tested as per the lab scale. So we cannot say that they are a base material. A base material is such material that can be tested in atmosphere, not at a lab scale.
Okay, sir. Dr. Ronak Shah is asking, after your research work, which type of solar still gave maximum pure water in a day?
Sir, actually the question is somewhat tricky. So let me answer in a very simple manner. Which kind of solar steel? So suppose I at present I am at Patan. Patan as a latitude is 23 degree. Okay, so there is one research article that has been published by Dr. G.N. Tiwari sir, and he has already concluded that whenever the angle of the latitude is less than 15 degree, okay, so double slope solar steel is better, and above 15 degree, single slope is better. Okay, so the solar steel, according to my perception, single slope solar steel is a better. Okay, but if you want require 20-liter water, okay, so best option that you have to use triple basin solar steel with evacuated heat pipe.
Yes, are you talking about G.N. Tiwari, sir, from IIT Delhi?
Yes, yes, yes,
Yeah, so
yes.
he was our expert speaker yesterday, sir.
I know, you know.
Yeah, yeah.
Actually, I have read many of his paper, and also he has helped me a lot during my PhD.
Oh, great, sir. So there are three more questions. Dr. R.D. Patel is asking, will desalination solve the water crisis?
No, sir, there is a abundant water is available in sea, so I don't think so. It's for crisis.
Uh, Professor Mayur Patel is asking, what is the future scope of solar absorption desalination?
Oh, uh, actually, I cannot share you that. Actually, I have one research project
Okay.
on the same. So,
Okay.
uh,
Okay. Yeah.
thank you.
Professor Samir Rawal, sir, is asking, would experimental readings for solar still performance differ in performed if performed at different latitudes for same interval of time?
100% it will affect,
Yes, sir.
sir. Suppose I am connecting experiment at Messana or some other same solar steel, same material at Delhi, USA. So definitely your readings will be different, your output will be different.
Okay, so that is it about the questions.
Thank
If participants have some more questions, we still have time and they can put their questions in the chat box.
Thank you very much, sir.
Thank you. Yeah, thank you, Hitesh
Yes.
sir,
Thank
Dr.
you.
Hitesh Panchal sir, for answering all the queries.
Thank you,
Uh,
sir.
yeah, on behalf of the team, I would like to propose a vote of thanks. So thank you very much, sir, Dr. Hitesh Panchal sir. On behalf of BNB Institute of Technology, the organizing team, and the participants, I extend my heartfelt gratitude to you. Uh, Firstly, for accepting our invitation on such a short notice. So, thanks a lot for that, right? And taking such a wonderful session and obliging us. So, thank you very much, sir. We really appreciate the work done by you in the field of renewable energy and as well as solar technology, solar desalination, and are grateful that you have shared your work with us. I'm sure you must have motivated so many of us with your experience and knowledge, sir. Thank you once again very much, sir. Thank you, sir.